Hello everybody, my name is Elena Vagnoni and I'm glad to present you today our project Machine Learning for the component fatigue prediction in hydropower generation, PAIREDHYDRO. This project is a collaboration between the EPFL technology platform for hydraulic machines, the Distributed Energy Systems Laboratory, and the Swiss Data Science Center. So the main research question that this project is looking at is how to early detect and minimize the fatigue damage for critical mechanical components of Francis turbines. Hydroelectric units are more and more required to provide flexibility to the power system to allow the penetration of renewable energy sources such as solar and wind, which are unpredictable, and so there is the need of balancing the electric grid. Hydropower is a perfect candidate for providing those balancing services, but of course this is not for free because the fatigue damage due to the operation of off-design condition and of transient operations is actually increasing due to those flexibility requirements. So there is an increasing need to having new methods to predict the fatigue and to optimize the operation of those machines. The objectives of this project, and the solution that we propose to solve this research question is first to create a multivariate model of damage in both steady state and transient operation by leveraging years and years of data coming from reduced scale model tests of different Francis runners that we have available in our laboratory. So by first having this multidimensional model of the damage in different operating conditions, we want then determine key indicators for the accumulated damage, in particular by looking at transient operations such as start and stop, which are the most damaging one, especially for Francis runners. Once we do have those models, that of course require advanced machine learning methods and cannot be studied otherwise with standard methods. Once we do have those model, we want to create an optimization algorithm that optimize the operating sequences. So optimization problem that define what is the best trajectory that minimizes the stresses of the damage during a startup sequence. So for instance, at the bottom right, you have evolution of the stress during time for a startup sequence of a Francis runner. What we want to see is how we can be able to determine what is the best trajectory that minimizes those stresses. The impact that we expect to have thanks to our project is to significantly cut down the operational costs, to propose new approaches leveraged by predictive maintenance, and also we expect to have a higher availability of hydroelectric unit by better supporting the energy transition.